Today we're going to be continuing work on the pixelize palletize thing. I've been thinking about it, and there are a few things that I want to change, one of which is instead of doing pixel size, I want to do like target size. So it's basically how many pixels. Uh, just create a mess that we can mess around with. Okay. Take this, put this in here, this, put that in there. So then I have this, and I control my pixel number. I think I want to do it just based on the size. So if I change this, then it just makes the pixel size the right size of a pixel. So we have pixel size here, and I think it's a float to size. So this is going to give us how big the thing is. And then we're going to do one for each pixel. It's going to break on really large ones if we do it this way, because the FX map can't do a thing per pixel on anything above a 1024. So here we're going to change this to integer 1, and instead of pixel number we'll just do target size and drop down list. And then we're going to do, somebody could do a 32 I guess. 64, 28, 56, 512, and we're going to put 1024 in here for now, but I think it's going to break. I'm putting the actual value in here because when you do get int, it gets this value. This is just the displayed value. So that will make it easier. As long as they're unique, it doesn't matter. So instead, I'm going to get integer pixel size. And we could try changing the name and see if it breaks. Does not. Yay! Okay, updated. So we will run into an issue if it's a rectangular image. And I'm going to just make a comment of that where this doesn't account for aspect ratio. they've been better at making things work across different sizes, rectangular, non-square. So I want to make sure that I'm putting that capability in. So it's going the opposite way that we want currently. Ooh. Yep, 1024 just gives us black. So can't do 1024. And then one of the things that they being algorithmic / Adobe does is they, instead of having it turn blank, they actually have it like wrap around. Let me test that. I can't really. It's 1024 times 1024 minus 1 is 1048, 575. So let's make sure this works. We could add that one back in real quick. Should give us 1. Oh, it can't go that far. 575. Okay. So then, if in here we wanted to get crazy, add a 2048, then we would get still nothing because it's way too large. So we're just going to have a break. And then, oh, basically just max out. So we're going to do the minimum between this and the absolute max. Ooh, it takes forever. only rendered part of it. Oh, because the total numbers, I know it's not working. Because I have to take this part, put it in with the grid. Because this number here is capping out. And then we have this size. Target size. Whoa, I'm gonna crash it. Maybe. Ooh. Okay, didn't crash it. We'll take those options out. Ooh. Okay, it's working. So then the other thing that I've been thinking about is our method for getting the closest color. Currently I'm converting it to RGB to XYZ, XYZ to LAB, and that is kind of expensive. So instead I think I'm going to do to linear and then just do the distance. And use this as my delta E. And I'm going to see how that works. So I just need 16 of these. So we're going to convert this to linear and then basically just use linear RGB as our distance. And then I think I also figured out a way to do, I almost feel like there needs to be a switch in here. The min-max stuff and get that to be a little bit more performant and support 256 colors in the palette. Which, if you're doing any sort of pixel art, you kind of need that level of control. Just 256 colors is pretty standard. I remember the first computer that I had that had 256 colors. You're like, turn it into high res. haven't really looked, but I've always thought that it'd be kind of nice to like duplicate a network while keeping the internal connections, but not the external connections. And I don't think there's a way to do it. Oh, snaps! That does. Ooh! I just did a shortcut for duplicate without link. And I've always thought that it just duped those things independently. Like, it would just take all of these and duplicate them without their connections. But it does. Ooh! So nice. Okay, I'll be using that from now on. Okay. Ugh. It's not a good way to, like... I mean, I can move all these. That's easy. Shift drag. Ooh, I should not be doing this yet. I gotta build the function. So we'll do that real quick. This is going to be select songs, zoom in. So this is going to have 16 float 4s, input 12, input 1, copy, paste. Okay, I guess this is going to be input 1. This is going to be input 2, because I don't really want to rename all of them. And then one more. Okay, so now we have 16 float 4 inputs. So what each float 4 is the color and its delta E value. So it's the RGB color and its delta from the input color, because we're trying to find the closest color. So then we have the color is and how far away from the desired color it is. So that way I can actually just pass the color. 6, 7, 8, 9, 10. So that way I can compare its W value, which is the alpha, and then just choose the color. So that way I can have 4 groups of 4 where the lowest delta will come out of each one, as well as the color. So it'll basically be, this is the closest color from this group. And then hopefully that will allow me to short circuit groups of 16. And it might be better to do it in groups of 4. But once I have this, I should be able to do smaller groups. So I'm just going to take all this, copy that, go over here, paste it. So then we need to swizzle out have the delta E for each of these. Function, function. What's your function? That's how it goes, right? It'd be interesting to have a Schoolhouse Rock for today's generation where they talk about computers and science, technology, and all that. Okay, so if this delta E is equal to the minimum, 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 then just pass this whole color in. If this delta E is equal to the minimum, 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 then pass that color in, etc., etc., etc. Otherwise, go through, check the next one, check the next one. Oops. Choop, choop, choop. It'd be nice if there was like a do similar, or like a G, like from Maya. Repeat. Put like, but Modo version, where it's intelligent enough to know what you mean. It's like, oh, connect the W to the equal and the color. Okay, so then what will come out of this, we're going to give it a bunch of colors with their distance from the target color, and then what will come out of this is, of these 16, this is the color and its delta E. That is the smallest of this whole group. So if we go into the pixelize formula here, we have this, and so what we'd be able to do is get rid of all of this and all of this, and I'm going to move this so I can select those mins here. Okay, so then we have all these delta E's for all these colors, so then we need to do a vector and put the delta E in the last, and then the color in the top. So delta E in the bottom, color in the top. I'm trying to make sure that I put the actual color in, because the conversions that we do don't matter for the color. We're not converting it and then rendering a lab space or a linear. It's just using that color space to find a better distance than just RGB. So one of the issues with sRGB is that it is basically computer vision. So one of the issues that we have is the difference between the way that a LED emits light and the way that our eyes interpret that light. So we have, and then we have other things like gamma, which is basically the perceived and inherent brightness of an LED. So we're trying to compensate, missed these two up, trying to compensate in our gamma for those different relationships. So then gamma corrected or linear, where we haven't messed with those colors, it's just the straight signal information, that's the useful bit. We want what's actually in the information rather than the way that's being interpreted. So if it's in sRGB, which it probably is, so that it displays correctly, we want to convert it to what it would have been before it got converted, to basically convert it back to what it was. So this we had a sequence, right? I'm going to pull these bits out. Whoa. Okay. Let's go to our test graph and see what we have. Hey, it's working. Looks really bright. So, gotta make sure that I didn't grab these lab colors. Just checking to make sure these go in the right plugs. Okay. Does all look good? And that... So everything's converting the same way. That's important. So we're going to switch our conversion now. sRGB to linear. Oh wait. Oh yeah, that's already done. So then I want to make a switch. It would make it easier to test, but then I have to rip out the switch if I choose which one I want. We'll just do it and rely on undo, I guess. This is one of those, like, taking something apart and putting it back together and hoping you don't have any extra screws lying around. So as you're like going down, connecting. Okay, no extra pieces. Oh. Whoa. Oh. Ha. I know why it looks the way that it does. Looked the way that it does. Did. That's because I'm not shoving the alpha. Oh. Auto level. Weird. I didn't know that was a thing. Okay, so the issue here is that I'm not throwing the delta E away. So the alpha is the delta E right now. It's all white. Let's use this. This won't throw everything away, will it? No, let's save. Okay. Hey! Whoa, that actually... okay, we'll go in here. This is where it would have been really good to have a switch. So now it's going more toward the brown instead of the gray. Okay, I'm gonna build a switch. Ugh. Just so I can A/B it. Yuck, but it's only going to be one color for now. Punk! What's going on? Yeah, working on some pixel arty nodes to palletize and pixelize. I should share a link. There's an external tool that's pretty cool. It's called like Pixar or something. Yeah, functions in Designer when you're doing lots of decision stuff is pretty tedious. Let's see. Pixa tool. It's a pretty cool tool. But yeah, I'm basically doing that in Designer. Unrelated. That was from a conversation in the Substance Discord where somebody asked if you could do pixel art in Designer, and I said, yeah, you totally can. I'm working on some stuff, and they're like, oh, that's cool, I've been using this. And then I said, that's cool. Ugh. Lots of strings. There's a demo that I want to say Nicholas did. Nicholas or Jeremy. Oh, messed up my wires. Where you could write out a function and then run the tool, and it would convert the code. You'd interpret the code and make the nodes for you. And I thought that was freaking amazing, but I haven't seen any of that since. Still waiting for that to be a thing. Oh, okay, I'm gonna go from the bottom to hopefully untangle some of these wires. Ah. That looks like it's all of them. And each one looks like it goes to the right one. Okay. So this is the delta E with lab, and this is just linear. It's like it's a taste thing. Which one I like more. One seems more correct, but then I like the other one more. Okay, so then this is lab, and this is linear. So the things that I'm liking about it is the saturation seems to be kept. Oh, wait. This is lab. This is linear. Ah. It's grabbing those greens in there versus not. So then I guess the real test here is calc time. I should expose that. And maybe the switch will just stay in there. Cooler. Okay, so I'm going here, get that boolean. look it up. Okay, so out here, it is way faster. It's just like random seed. Yeah, it is twice as fast to do the linear to RGB conversion than the lab. What's interesting too is that like these darker shadowy pixels in here, like this, these really dark areas, those get fixed basically in the lab version. You don't get those kind of artifacts. Yeah, it's like consistently twice as fast. The lab version, you get more color in here, a little bit more green variation. I mean, I can keep it because it's just making it faster. So I could change this because the user might not care the science behind it. If that makes sense. And then I could just call this, well, I can keep it color mode and call it, the true one is, we'll call it accurate. And then in the description, and we'll default it to false. So then when you're in here, you see this, and then you can mouse over it and see what it is. Maybe I'm going to add color to the label. Accurate color. Cool. Okay, so 16. This is only working with 16 samples. So one of the things that we could do to speed things up a little bit would be to take this info and put that into a function with the switch, which is what I'm going to do. Grab this, grab this, and this. Maybe not. I'll just make it. Wait. Whoa! All right. Crash in Designer. Let's see how often I saved. Okay. Color mode. Accurate color. Okay, cool. That's all there. But our little play around graph is not. So then bring this in and to cliff. No, that was cliff. calculation times aren't nearly as different. All right, it's fine. So this stuff, this is going to be so this stuff, this is as simple as I can get it, I think. So dang it. Okay, here, things we need. We need this number. We need the input lab, and then input linear. So, wait, yeah. So we need our RGB weights. We need our color target. This is our RGB weights. And we could put the RGB weights inside, but we don't want to do that because then we'd have to like expose that or something as a variable if we want to change the weights for all the colors that we're converting. Float 3. This is our color target. Oh wait, this is color target in lab, and then we have our color target in linear RGB. Because this is basically our input color. So then we need one for that. Color input. Okay, we can get rid of that. So then we need this conversion, and then we need distance. Color target, linear RGB. So we're going to get the distance between these two. And then we have a Boolean for our color mode. Color mode true. be some and I'm going to reorganize these, I think. So the first thing we'd want to go in, so from a UI perspective, we'd want our color input to go in, and then we'd want, actually no, first thing we'd want is which mode, and then reference lab, yeah. And then we want to pass the whole color out, right? So that's following our same format. So then for this, so we're going to return RGB color and okay, so this, sure, saved. Our delta E mode, we give it the color, the reference XYZ, and then the Boolean, and our color target in lab, and our color target in linear. And then this is the thing that goes in here. But we're gonna do that in a sec. So these twisty wires is kind of annoying. I might reorganize the mode. Okay. So then we need another one of these, and the only thing we change is its color. Another one, change its color, another one, etc., etc. Okay. So those are hooked up. This one, this one, this one, this one. Ugh. Tedious. And this is basically testing before you make it work for 256 colors. which is 16 times what this is. Alright, so then I pop back over here and, oh yes, okay, still works. Yay! Okay, and then we change our color. Yay! Okay, so if we wanted to thinking if it would make sense to put all of this in into a single function. This number is our palette at 4 by 4. So if this was to be made into a single thing, then we would need an offset for the columns, rather for the index. And we can't sample inside of a function. At least I'm pretty sure we can't. Let's test that hypothesis. Function. Just trying to rename you. Rename. So this just gives me a whole bunch of things. And I can't change this, can I? I can't type in here. So in the case that I have more than 14, or I guess it would be 15, more than 15 images to sample from. But wait, I'm only sampling from input image 1. So if I say 1, I guess I could just try making this into a function. Well, I really just want to try to replace this bit. So we'll have a float 2, and this is our position. And this is our output. So let's see if it totally breaks this sample. So we're getting grays in here, like these last two grays, so I'm going to try those ones. Oh. Whoa. Okay, so I've tangled these all up. I've sampled 4 colors, and it's not breaking yet. At least based on what I can tell. It's either totally broken and it's no longer calculating, or this works. Oh, wait. Some pixels changed. Whoops. Okay, we'll just try replacing all of these. Oh boy, it works. Okay, that is really freaking cool. So let's save this, go in here. If I change this to and put 0, it changes the thing that I'm sampling. So this image input is basically hard-coded. So for this thing, I don't want this in my library because it won't work with anything else. Oh, I read that as pixel processor, and I'm like, yeah, all the time. Value processor, yes. One of the things that, like in this use case, we could calculate the delta E values in it for each one, and then pipe that into another thing and just use that as a switch. What else? If you're calculating like average color on an image, or the min-max, or anything that you want to calculate in one place and use somewhere else, it's super useful. If you want to test a number before exposing it as a parameter, it's also useful. At work, we're on an older version where we don't have this, so I haven't had a lot of time to play with it, but I've started using it in some of my graphs. Because you can take a parameter and calculate a bunch of different things and push those into the different nodes that you need. So one example would be, instead of like creating a function out here and having that in, like, let's say the base color of this, we'll just use this example. So if for whatever reason I needed to have 2 of these, and I needed a function in the X amount, and I wanted it to be the same based off a parameter, I could create a function out here and put that in both of these, or I could calculate that here and put that into this. For example. So I could calculate my X amount that I need. And then if that changes, if the function here changes, it's used in both. So it's a way to do something that's graph specific without necessarily creating a function in the package, which is cool. I might use it on this project, we'll see. Okay, so we're going to rename this, and this is going to be sample palette. Yep, let's update all of those. Okay, the sample palette is this. I can make an assumption about no, I don't want to make any assumptions. Okay, I'm going to copy this. I just need column row, I think, which is another thing that I have in here. Column row to get the position of the thing. So we're going to need, we don't need position anymore. So this is our index. And that's a float. We're going to do some pretty serious nesting. This is an integer 2. This is our palette size. Knowing what the palette size is, to float 2 sizzle. One divided by that. Gonna keep our types correct. Okay, because we know our palettes are going to be a square grid of stuff. So we have our palette size, index, and then sample it. Okay, looks like it's working. So then just pop all of these off. And hook this up. I'm holding control, which allows me to hook all those up. Okay, So this function is getting a little bit smaller, a little bit nicer. So then we could make, oh wait, we don't need any of this because we do it inside the sample. So then we could take all of this and make it, not too, its own thing, because we don't need this anymore. This might be easier to read in a different format, which we could do inside. So what we would need is basically a function with this stuff exposed, this exposed, and an offset. So I'm going to save and then create a graph from that. We're going to call this sample 4x4 palette. So then we need some flip 3s, which is our elements here. So this is our color target lab, our color target linear RGB, our color weights. These are all flip 3s. Get our target, our weights, and we need that boolean. This is color mode. And we'll hook these up. Perfect. And then our color weights. Just the third one, third. And then our lab target. Just control clicking again. Control is basically copy the input, and you can copy from either here or here, which is really nice. So we have all these. Put those on a Okay, so the thing here that's a little confusing, if we undock those, is that we are just going up the indices, and if we start at a point, then so let's say we go 0, 1 through 15, and then we need to get the next ones in the palette. We then have to start at an offset. So since this is a function, we need to be able to give it an offset. So we'd have to get basically an index offset, which would do an integer. This will be the first thing. So then get int index offset. So then we gotta add, whoop, not and. Whoa, crashing, maybe. Woof, boom. Save often. It's just a shame that it doesn't save my view setup. And then our playground. No, stone. Stone mossy. And stone. Okay, cool. We lost this. I'm going to keep those for reference. I called it 4x4, but I actually don't know if that's what I want. Okay. Float 3, copy, paste, paste. This is our target lab. Target linear RGB. This is our weights. Then this is index offset and color mode. They say things are faster the second time you do it. And I think that's because when we do things, there's a lot of problem solving that we do, whether it's I guess clear or not. Like trying to figure out edge loops on a model, or like the general shape and form of things. And once you've gone through that problem solving exercise, redoing it doesn't take nearly as long. The longest part is figuring out the how part, usually. In this case, it might be the same amount of time because this is super tedious, connecting all this stuff. So losing work sucks because you basically have lost time. But it does give you an opportunity to rethink through it, which can be good. And then you are working on the other skills that you're using instead of the problem-solving ones, which That's definitely a silver lining, the whole losing work thing, but it helps you not be as attached to the work. At least it works for me. I work with people who flip tables after they lose hours of work. And my first question is, how did you lose 2 hours of work? You should have been saving. Then don't be so attached to your work. And just try to think that it's an opportunity to get better, to improve, to think through things more clearly because you've already figured out a bunch of unknowns. Oh, nice. What's the functionality that you added to your tile sampler node? So I'm going to do, you start at the index and add 0. And then the next one, I'm just going to do, or take whatever the previous one was and add 1 to it. Because I basically need an add in here anyway. So I'm just going to take whatever the previous one was and add 1. And I'm going to get rid of all these. It's less opportunity for me to just totally mess up my numbering, which I'm really, really good at. So take whatever it was and add 1. That's the next index. And that's a lot more clear to see what's happening, I think, as a user, that we're starting at the offset, whatever that is. If this isn't given anything, it should be 0. And then we add 0 for the first one, because that's our starting point. And then each one, you just take the previous one and add 1. Yeah! Are you using like a rotation map, or are you using vector map to do the rotation of each one? And yes, organization, especially when you're coming back to it, when you don't have to spend 20 hours figuring out what the heck the graph is doing, or how it's doing what it's doing, oh, it helps a lot. Oh yeah. That's kind of what this is doing. So this is our grid size. We need it, our palette dimensions. Get integer 2, palette dimensions, connect that. So I called this 4x4, but it's not really 4x4. It is sample palette 16. So for those that are curious how to do that, so what I'm doing up here is doing some stuff, figuring out the position of where that pattern input is. So we're making a bunch of squares, a bunch of white squares basically. So we're making a bunch of white squares, figuring out their size, and then figuring out where they need to be placed based on a grid. So it goes 0, 1, 2, 3, 4, 5, 6, all the way across. And then when it gets to here, it basically takes the number of items in that row. So let's say there are, I think there are 30 in here, 32, yeah. I should add another one for 16. So there are 32 squares across here. So the number of this one is basically, it's numbered, it is 32 because it starts at 0, but 32 minus 32, and then that gives me the horizontal offset. And then vertical offset is just how many times it divides evenly into 32. So this is 0 times because it's lower than 32, and then this is 1 time. So that's the row column stuff in here. So then once I know where it is, then because the center of the FX map is negative, or is 0, 0 is here, I need to go negative, negative, so that things start in the top left. And then once I have the position, I can sample the other color that's in it here, the image sample, and then I have some blurred stuff to get a better color sampling. So I sample those colors, and then that gives me the color underneath that square, and then I convert that, and then I run it through the palette stuff. So that's how you would do the rotation or color or luminosity. In this case, we're doing the color, sampling it based on the position of that FX map item. So color mode, color weights, we need an integer. We have one right here. We don't really yet. Go in there. We don't have an index offset. Our lab color, our linear color, and then this should be our output node. Save, go back here, and it still works. Ha 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 ha. Yay! All right. So, since that works, that means got all of this here we can get rid of. Shrink. And we can take all this nonsense, just put it over here. And we'll use this in a bit, but let's swap these. The order of these is a little bit wrong, so save. I can do this. Not that it really matters. Color mode, I'm going to move up. And color weights need to go above linear. There we go. Untangle those wires. And then move the offset down. So we have a thing that samples a 4x4 palette currently. And we would like for it to be able to sample more than that. So we have this select min delta E, which we could make one that's 4 and then put 4 of them in this, or we could just duplicate this, and then really this is going to be a 16 by 16, and then this will be offset by 16, and then this will be offset by and then we're going to see if this works. I have a feeling it's going to come apart because of calculation time. Each one is going to sample up to 256 times, which is a lot. So in order to get these min values, all of these have to be calculated, which kind of sucks, but it's the only way to get an accurate palette. Wait. There we go. So we should get the same thing. Okay, so it is not sampling the entire palette, or change these labels. Okay, so it's not sampling correctly, which is not unexpected. Now we just have to figure out why. So this is the dimensions, and then our column row. That should be working correctly. And then so it starts at 0. Okay. Hit this open. That's 0. So it goes 0 to 15. So then we want it to start at 16 because our sample palette 16 is offset plus 0. So the first one would be 16. And it goes 0 to 15. So good, that's the next one. So then it's going to go between 16 and 31. So then we take 16 plus 16, and then we start it at 32. Perfect. And then that's going to go between 32 and 47. And then we add 16 again. Oh. Thanks, Punk. Catch you on the next one. So the reason that this is incorrect, or not really working, is because I need 16 of these. So this select min delta E is going to be full up of this. So each one of these, I'm going to take the previous, add 16, offset it. All right. It looked a little bit small. I was like, I'm going to sample 256 pixels. This graph seems really optimized. How many more is this I need? 2 more. typical. It's black. Maybe this will become a function too, we'll see. Ooh. Oh, the calculation time to end up all green. Yeah. It's not working. It's exponential calculation time, it seems. So yeah, 16 is 26 milliseconds, which is long, but not that bad. And then 32 is 77. And then 64 is 284. And then 1,000. And then 4,000. And then 512 is just going to break it. Basically, it looks like we're sampling between the top two ones, which is not what we want. Okay, so we're going to do this. This is okay, 80 milliseconds. It's okay. So all of this math is correct. This is a 16 by 16. So the offsetting portion should be correct. So we take the index and we just add 1, which is fine. We have the dimensions, which is 16 by 16. So then we sample the palette. Let's see. So the palette is 16 by 16. And then the size, we're assuming, are square. You could mess with this. Okay, so that didn't change, which is good. It's just 3. This isn't changing it. This doesn't look like it. So we have all of our stuff, delta E, then we choose the lowest. Okay, well we already knew that that was working. Delta E mode, we know that this is working. Presumably, we should test that to see if the colors change. Okay, the colors changed to other greens. So it's dark. Okay. 99, 44, 79. Okay, so it's the top row of the palette. And maybe this one, and maybe this one. So we're just going to rotate it to see what we get. Brown, gray, and green. So top row. Just gray, presumably top row. Gray, brown. One light gray, so top row. So it's just sampling across the top row, which is not exactly what we want. So our row column offset stuff is not working the way that we want. So we can change the palette dimensions. We can see if this changes things. It does. Looks like it's sampling down in here. Okay. So what are the palette dimensions? They are 16 by 16. And then we're offsetting it for each new one. So we're basically sampling across the top row, second row, third row, fourth row. So then so this is 16 of those. We just offset the index, which is good. And we'll look at this. So that's pattern size, palette size rather. So the palette size is going to be 16 by 16. And then the size of each of those items is 0.065. And then the index so the column row looks like it's functioning properly. Because if we go here, look at this versus this, the colors are all correct. So the column row portion wow, it takes forever to switch between these. All I did was change the thing that was being sampled. So the way that we're parameterizing the palette might be incorrect. Ooh, what a thing. So the first thing is going to be 0 plus 0. The index is 0 on a 16 by 16 palette, so it should sample so just using this palette should basically we should be sampling each of these quadrants. I guess not quadrants. Whatever 1/16th rant is. Each of these sections 16 times. So it should just take longer to do exactly the same thing. So okay, I'm going to swap this one in. So that's behaving correctly. That's behaving correctly even though it has an offset of 16 because it wraps. So that means this works given so this is sampling across here. I would expect each of these to give me a different looking palette. Each of these should be giving me like a row. Oops. So what's weird is these multiple grays. Like all three of these just gave me the same thing, which means that they're sampling from the same or similar areas in the palette. As opposed to this one, which is sampling across a different row in the palette. Okay, these are repeating, which is what it should be doing. What? Okay, I think the sample palette 16 might be the thing. Aha! Okay, so I have to do this at the very end because I'm basically throwing away my delta E value. So these are all passing the whole thing with their delta E and everything and the color, and then it passes it into here, and then all of these have basically the same value, 1, because I threw it away at the end of this. So this is where we do the swizzle float vector. Ha-ha! Okay, now it's working. Save. Okay, it's giving the same thing, which is good. It's giving us... It's sampling 16 identical palettes, which is not exactly what we want, but that's fine. Create palette. We could go grab some other stuff if we want. Let's see. This is not very fun, but let's pick some colors. It's hard to sample from one of these images because it is like all the same. This color looks different. Oh, because it's next to this other color, so it's not different. It just looks like it is. Okay. What do I need? 1, 2, 3, 4, 5. So let's try that one. Do accurate. And then this one. I got some different colors in there, which is good. It's pretty cool. Textures without like definition in them don't work very well. Like these are pretty noisy. They're not like bricks. But yeah, it works. So it can support 256 colors. Unless the user sets up their palette so that it doesn't have wasted space. So for example, this. It's the same calculation time. And there's a question of whether or not it supports transparency. I could say that it doesn't support transparent colors in its palette. And then have it error out. I could also have it slice these and stack them in here instead of doing this. But in this, I could probably I do palette size. Min is going to be 4, max is going to be 16. Clamp it. Default we'll say 4x4. So let's see if just having that totally breaks it. Yep, So I have to figure that out. Because this palette is basically 8 by 4. I might be able to just skip these. Nah, man. So the next thing that I'll need to work on is figuring out how to skip palette sections that are blank. So in the case that you have a palette like this, or maybe a palette like this, that's not full. So maybe we do this. I can't do anything about this empty one, but if you give 4 by 3 on that palette, then it could work still and not totally blow apart. So basically, if the index is greater than yeah, I'm gonna have to think about that. But today we've got a different delta E mode, so that we could do something that's a little bit faster. Let's see. It's about, with the larger pixel versions, ooh, okay, 19 versus 1950 versus, ooh, so it's about 2 times faster. Yeah, about 2 times faster. So it's about twice as fast to do the cheap one. Yay! Cheap sampling that also gives a decent result. This doesn't do anything for right now. And it supports up to 256 colors. I wonder if I could find one. Why is it 384? I'm just trying the standard Windows 8-bit palette. Which did not bring it in. Does it work? Okay. I don't want it to be that big. I want it to be um, okay. Pretty close. Pretty cool. Accurate. Yeah, it's getting a lot of that kind of nice subtle color variation in there in the accurate version. This is just kind of muddying it together. There's a lot more like purple in there and stuff. Like, just do a quick compare here. And we're gonna crash everything, so here we go. Ooh. Pretty cool. Yeah, I'm actually pretty happy with what that's doing. And this rock is like, it's pretty noisy. All this like color variation. It's like zoomed out. This almost looks pixelated, and it kind of matches that, which is really surprising. I would say that that's because this material is really good. The moss feels fuzzy, the rock feels rough. What's my normal look like? That's the pixelated version. Yeah, so I got to figure out how to bring the performance to where it needs to be and do better sub-paletting with that. Like generating the texture is 266 and then, or 215, and pixelizing it is 135. It's not too bad, but once you go up to any of the larger sizes, especially with accurate color, it gets a little bonkers. Oh wait, I also have this, I think, quantize normal. Um, 2, 4, and 16. pixelate the normals too. Ooh. Definitely would need to give it a palette for normals and height and stuff to kind of pixelate the whole thing. A lot of chromatic stuff happening in there. Just getting squares. It's pretty cool. It is interesting that based on this palette, which does have some grayscale in it, it introduced a lot of color. So yeah, basically performance-wise, we definitely want to bring these guys into a more performant range, especially if you want to have the larger resolution. Yeah. We crashed Substance 3 times today, so probably related. These will probably go onto my ArtStation when I'm done for sale in my Gumroad. Yeah, so feel free to follow along. You could build your own, basically, if follow all the streams. So thanks for hanging out and doing some math with me. And we'll catch you guys on the next one.